Welcome to Department of Anatomy, Faculty of Medical Sciences, University of Sri Jagadampa. Today, we will be demonstrating how to prepare a normal histological slide with an H&E staining. Mr. Nuwan Pereira, who is our technical officer at Department of Anatomy, will be assisting me in this operation. This is the microtome blade sharpener. When we are taking a wax block for the microtome, we need to trim the tissue first. So, in order to trim the tissue, we have a trimming blade separately. So, this is what we call the trimming blade. So, this equipment will sharpen up this trimming blade before putting it on the microtome. Mr. Nuwan is operating the microtome blade sharpener. He is fixing the trimming blade into the machine. Then he is adjusting the blade, and then he will switch on the machine. So, as you can see here, this machine will automatically sharpen up the cutting edge of the trimming blade. Now, we are moving towards the microtome. This is the next step of tissue processing. Now, first we will identify the parts of the microtome. So, now we can see this, the black color knob is the place that we can adjust the thickness of the tissue. Below that, you will see a handle which will alter the position of the stage. And in front of the microtome, you can see the stage. So, this is the stage where we will fix the trimming blade as well as the normal tissue sectioning blade. On top of the microtome, you can see the place where we are going to fix the embedded tissue. On the other side of the microtome, this is the rotating wheel. So, manually we have to rotate it, and on top of the rotating wheel we have another lock. So, by unlocking this lock, we can manually rotate the microtome. Now, we are going to fix the trimming blade to the microtome. This is how we are going to fix the trimming blade. After fixing it, we are going to fix the embedded tissue to the stage. Like this, we can alter the stage and fix the embedded tissue to the microtome holder. Now, we are going to start the trimming of the tissue. Before trimming of the tissue, we need to place the adjustment mark to the R position in the microtome, and then rotate this wheel and try to adjust the tissue stage and the microtome blade according to this. Then we put it to the micrometer 15 position, and then we start the trimming. The basic idea of trimming is remove the excess amount of wax in front of the tissue and try to take out the unnecessary wax and merge out the tissue section. After trimming the wax block, we are going to leave the tissue with the wax block on the cooling pad for at least 10 minutes. Now, after leaving for 10 minutes, we need to manually check whether it is adequately cooled down for the next step of tissue cutting. Now, we are going to put the microtome blade into the microtome. Now, as you can see, this is the tissue sectioning blade which we are using for the microtome. As you have seen previously, we have removed the trimming blade, and now we are going to fix the microtome tissue sectioning blade. Now, after taking the trimmed tissue from the cooling pad, we are going to fix it to the microtome holder. Then we are going to adjust it to the 4 micrometer position, and then we will start taking the tissue ribbons. So, usually we are taking it at the 4 micrometer position. So, as you can see here, very nicely the tissue ribbons are coming out. This is how we are obtaining the tissue ribbons, 4 micrometer thickness tissue ribbons from the liver tissue. This is what we call as the tissue ribbon. Now, we are going to put this tissue ribbon, which we have obtained from the microtome, on a glass slide, and then we are going to put some 30% alcohol in order to remove these frills. So, if you think 30% alcohol is not enough to remove the frills of this tissue ribbon, still you can use the 50% alcohol. After putting it on the 30% or 50% alcohol, we are going to transfer the tissue section or the ribbon onto the hot water bath. The hot water bath is at 40 Celsius. This will further remove the tissue frills. In the hot water bath, we can clearly remove the tissue ribbon and break down the tissue ribbon into small segments, which we can take up to the normal glass slide. Now, we are going to obtain the tissue section onto a glass slide. As Mr. Nuwan Pereira demonstrated, we put the glass slide on an angulated manner and slowly raise the glass slide as the tissue section, as you can see here, very nicely without any frills, fixed on the glass slide. Now, we are going to keep the glass slide with the tissue on the slide dryer. The slide dryer also switched on before the process, and we are going to put it to the 70 Celsius. Now, we will move on to the next step of the tissue processing, that is the H&E staining. For the H&E staining, we have obtained a tissue onto the glass slide. So, we will put the glass slide on the tissue rack. So, after that, we will be dipping this tissue with the slide on the xylene baths. So, each xylene bath will have 2-minute sections. So, the reason behind having this xylene bath is to remove the excess amount of fat and in the paraffin wax. So, after 2 minutes, we will be moving to the next xylene bath. Then, after another 2 minutes, we will be moving this tissue to the absolute alcohol. So, in the previously, we have used the ascending concentrations in the tissue process, but here we will be using the descending concentrations. So, we will be starting from the 100% alcohol to the 90%, then into 80%, then into 70%, and then into 60%. So, each bath will have 2 minutes time. After coming to the 60% of alcohol, we will be moving to the hematoxylin staining. In the hematoxylin bath, we will be leaving the tissue for 5 to 7 minutes. After keeping for 5 to 7 minutes in the hematoxylin bath, we will be dipping the slide in the plain water in order to remove the excess amount of hematoxylin. After dipping it, we will be dropping it into the acid alcohol bath. Now, after keeping in the acid alcohol, we will be dipping the tissue in running tap water for 7 minutes. Here, we will remove the excess amount of hematoxylin and try to get the hematoxylin color, because the tap water is basic. Here, in addition to the running tap water, we can put some liquid soap also in order to, if you want to enhance the hematoxylin staining color, because the soap is having a basic pH. After keeping the tissue section in the running tap water for 5 to 7 minutes, we will be coming and dipping the section in the Eosin bath. In the Eosin bath, after that we will be keeping for 30 seconds, and then we will be moving towards the absolute alcohol 2 baths. After dipping it in the absolute alcohol 2 baths, we will keep the tissue for dry. Now we will dip the tissue after staining in another saline bath and keep it outside for at least 5 to 10 minutes in order for the silane to get evaporated. So once the silane is evaporated, we can go for the mounting of the cover slip. So either you can keep the slide at the room temperature, or you can keep it at the incubator for nearly 5 to 10 minutes in order to evaporate the silane. So we will be moving towards the final stage of the tissue processing. So the final stage is putting the cover slip with the DPX. So initially we will take a cover slip and place it on a tray and put a drop of DPX on the prepared slide. As Mr. Nuwan Pereira demonstrated, we put a small drop on top of the tissue. So one drop is enough for one slide, and then as Mr. Nuwan Pereira demonstrated, we turn it around and slowly putting it on the cover slip without having air bubbles, and then we leave it for air dry at least for another 20 to 30 minutes. After the fully completion of the slide, you can see the liver tissue is very well nicely placed on the slide with the cover slip, and after that it is very important to label the slide with the human tissue, liver, and which section is a transverse section, right? And after that we will be putting it under the microscope, first under the low power, and then examine for the features, microscopic features under the liver or under the microscope. So we adjust the stage and then we observe the microscopic images through the light microscope. Thank you.